So is it possible to have an equation that has an infinite number of solutions? So a couple of words in there we just want to quickly review to make sure we know what we're talking about. Equation is like a mathematical sentence that has an equal sign in it. Infinite means like limitless. And the solution is, remember from previous sort of lessons, it's finding a value for a pronumeral that makes the equation true. So we've been doing some kind of simple ones like this, right? X plus 3 equals 5. You can look at that and you can just see, well, X needs to be 2 to make that true. That's the solution to that equation. And there's only one. There's only one solution. There's only one number that makes that true. No other value could go in there and make that equation, or the left-hand side, equal to 5. There's only one solution. We looked at these ones that had squared in them. And remember we said undoing that was square rooting. But when I square root, I end up with two possible solutions, a plus and a minus. So in this case, I'd say there's two solutions, plus 2 or negative 2. Although sometimes there's actually no solutions at all, because if I try to square root a negative number like this one, I'll get an error and we say, well, that has no solutions. So is it possible to have an equation that has an infinite number of solutions? Well, kind of. Looking at this thing here, x greater than 3. Now, it's not an equation because it doesn't have an equal sign, but it's kind of like an equation. We call it an inequality or an inequation. It's like an equation, but it doesn't have an equal sign in it. But it's still, there are still numbers that would make this true. There are still numbers that are greater than 3. Okay, and here is a way we can visualize them on a number line. So here's the process for plotting these inequations onto a number line. The first thing we're going to do is look at our number, and that's where we're going to start. In this case, we're going to start at 3. Now I'm going to put an open circle here because 3, the actual value of 3, doesn't make this true. Like if I replace the x with a 3, 3 is not greater than 3. So 3 is not included, but that's where we're starting, so I put an open circle, right, with space in the middle of it. All the numbers that do make it true are these ones. 4 is bigger than 3, 5 is bigger than 3, 6 is bigger than 3, and is there an infinite number? Well, yeah, they just keep going on. 4 million is bigger than 3, 200 billion is bigger than 3, so it goes on and on, so I indicate that with a little arrow. This little diagram is a visual representation of the solution for this inequality or this inequation. Okay, let's have a look at another one. I'm going to put that one aside. What about x greater than or equal to negative 2? So this symbol, if you're not familiar with it, is like a greater than sign, but it's got a second line underneath here. And this means greater than or equal to. It's kind of like there are a couple of options. So we're looking for anything that's greater than or equal to negative 2. Now in this case, I'm going to start at my number, negative 2, which is down here. Okay, I'm going to put my circle. However, this time I'm going to color that circle in because negative 2 does make this true. Negative 2 is either greater than or equal to negative 2. So if our symbol is this greater than or equal to, we color in the dot because negative 2 is included in our list of solutions. Now I'm looking for all the numbers that are greater than negative 2. Well, once again, all these numbers to the right, are greater than. So you can see the greater than symbol is pointing to the right. So we know that all the numbers up to the right, and just like the previous one that goes on forever, so I put the arrow. This is the solution, or shows the visual solution to this inequality. What about going the other way though? What about if I had something that was less than? X is less than 1. I'm looking for all the numbers that make this true. I'm going to start at 1. I'll put a circle. I'm not going to color it in because it doesn't have the bottom line on it. It's not less than or equal to. And I'm looking now, this points to the left, so my line is going to go to the left because I'm looking for all the numbers that are less than 1. Okay? Everything down here makes this true. Negative 5 is less than 1. Negative 6 is less than 1, and it goes on forever. Similar to the previous, or the example before that one, this one has less than or equal to. So I know my dot's going to be colored in because it's got this second line under it. It's x is less than or equal to negative 2. So I'm going to go to negative 2, put a circle, color it in because I know negative 2 will be included in my answers. And once again, I'm looking for all the numbers that are less than. My little arrow points to the left, so my line will go down to the left. All these values are part of their solutions. They're things that make this true. Now, the only thing you might want to watch out for is if you get something like this. X plus 2 is greater than or equal to 5. Now, this looks a lot like those simple equations that we've been doing in previous lessons. And we can do the same things, like we can move things around exactly the same in most cases. I'll explain. No, in this video, I'm not going to get tricky. We'll save that for another video. So if I want to get the x on its own, just like I want to do when I'm solving an equation. So I'm going to take this plus 2. When I change sides, I change sign. So that plus 2 comes across to the other side. It becomes a negative 2. And 5 minus 2 is 3. So now I'm going to plot on my number line x greater than or equal to 3. So I go to the value 3. I'm going to put a solid dot because it's greater than or equal to. And all the numbers to the right, because it's pointing to the right, are part of my, let's get that back, part of my solution. There's meant to be an arrow there. Yeah, I'll put that on. All right, there you go. That's a little intro to inequalities and how we can plot them onto number lines to visually show the solutions. And yeah, they can have an infinite number of solutions because they go on forever. Well done.